we need more power. Okay guys, sorry about the sound. I got the wireless microphones kind of dragging them around, so apologies if it gets kind of scratchy. Anyways, in our quest on the HDT, if you previously watched any of the videos on that, we added 620 amp hours of lithium batteries to the truck already. And I'll get up there in just a second and show you that, where we already put those. Anyways, they are doing absolutely fantastic. As you know, we do not run a DC to DC charger, and I'm running the lithium in conjunction and parallel with the 4 commercial AGM batteries for the starter motor and the engine and all that stuff like that. So it's been doing awesome. I did deplete the lithium batteries down pretty hard the other day, and we're going to go ahead and be installing a DC to DC charger. I still don't think that you really need one, but like I say, I did run the batteries down almost down to probably about 10 or 15%. And when I cranked the truck back up, they were taking about 80 amps. So I don't want to put the alternator on the truck in a bind because, well, the DC to DC charger is much cheaper than buying a new alternator for the truck. But anyway, it's still no reason to have to run a DC to DC as long as you limit, how much battery you have, which leads us to this. We already have 620 amp hours installed, and I purchased the other day another 620 amp hours of lithium batteries. So do the math. We're going to be having 1240 amp hours of batteries in Vader the Volvo, the HDT. With that, I had already done some testing on running the mini split air conditioner off of the 600 amp hour battery bank. I've got it wired in, and again, I'll show you all this up here in a minute. I've got it wired in where I can transfer the load to the Mini off of our 3000 watt inverter. And with the Renogy battery monitoring system, it showed that I would have about 6.5 to 7 hours of runtime just on the 600 amp hour bank. And that was during the middle of the day, so the mini split was running pretty hard. Of course, at night, once it cools down with the linear compressors and the linear motor, blower motors in there, that load would go way down. So we're going to add more lithium batteries, and hopefully we're going to get this truck eventually where we can just run the mini split and everything and not even have to worry about a generator. But anyway, I got on. Now don't shoot the messenger, guys, okay? Just listen here. Lithium battery technology has gotten so prolific now that there are literally hundreds of suppliers of lithium batteries. About 95% of those come from China. The lithium market here is just not, anyway, it's just much cheaper. I know there are you diehard folks out there that swear that you have to have battle-born lithium batteries because you like to buy names. They are way overpriced now in the market. Years ago when lithium battery technology first came about, yeah, your only choice was battle-born because they were the only people that were kind of building them, so they could set their price point very high. Again, I know, made in the USA. Guys, their lithium is not made in the USA. I don't care what they say. So they are assembled in the USA, but they are not made in the USA. So again, jumping way forward, the 620 amp hours that I already have in the truck, I built those batteries myself. I bought raw cells. I assembled them with a BMS. They were very cheap back then. I think I still had less than $1,000 even tied up in those for 600 amp hours. Now, a 100 amp hour battle-born battery will run you about close to $900. So for me to have the same 600 amp hours, $900 a piece, would have run me about nearly $4,000. Again, jumping forward, lithium batteries have gotten so cheap now that honestly, it's almost not worth buying a conventional battery anymore, other than the fact that lithium technology is still a little behind on the curve for like starter motors and stuff that take really high loads. There is a company out there now that is building 8D lithium batteries that they are starting to install in these big HDT trucks, and they work great for starter motors. They are still very expensive though. But again, they've got the technology in there to handle loads like the starter takes on this truck to start. It has a 12.9 liter, I think it is anyways, engine in it, and it takes a lot of oomph to start it. So we're not quite there on lithium yet, but still, for what we're doing, can't go wrong with lithium batteries. Now, let's talk about prices. Again, you remember how expensive battle-born batteries are. What I have right here in these boxes are 310 amp hour a piece 8D lithium batteries, and guys, here it is. I'm going to put a copy of the invoice up on the screen. $324 for the both of them. Okay. And again, don't shoot the messenger here. I'm just sharing the information. I bought these on Temu, and I know, here it comes. Everybody's like, oh my God, they're junk. Nobody would want to run that stuff, blah, 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 blah. Well, I'm going to say BS. It takes a little bit of homework though. You have to look into the manufacturer of the battery. You have to make sure that they are a reputable manufacturer, and you have to make sure that they are building a quality battery. But there are cheap lithium batteries on the market nowadays, and I have to my door, delivered from a warehouse out of New Jersey, ordered off of Temu, $339 total in this 620 amp hours of lithium batteries. These batteries have a built-in BMS. They have low temp shutoff. They have high temp shutoff. They have overcurrent charge protection. They have anyway, the built-in BMS in these is very good. The BMS in these is a 100 amp BMS. So a little on the low side, but not to worry, because again, remember, I already have 620 amp hours installed with two 100 amp BMSs, and those are in parallel. So just off of those batteries, in theory, we can draw 200 amps. These are 100 amp a piece, and they are going to be in parallel with our other set of parallel batteries. So again, in theory, we have another 200 amp BMS here. We are not ever going to draw over 200 amps off this truck, ever. I don't care if I'm running the microwave, the mini split, and the water kettle all at the same time with the disco ball going. It's not going to happen. We have plenty of BMS. Again, since each individual battery out of all four of them has their own individual BMSs, we're protected there as well on overcurrent and under voltage. All right. So let's pop one of these out, and I'll show it to you right quick. And it is surprising how cheap lithium batteries have got today. Okay, here we go. Now again, I gotta get okay. Again, sorry guys. Let me get this up here just a little bit more. There we are. Okay. So I don't know how to pronounce this. Okay, but I have bought a couple of these batteries already, and they are installed in the Class A also. This is by a company called, I don't know, HumSync, whatever. I don't know. And again, I already know what everybody is saying. Oh, it's Temu junk. Guys, it's BS. These batteries actually work really good. We have put them through some seriously hard paces already. I have zero complaints, okay? And $339 for 620 amp hours with built-in BMS, okay? So, anyways, here is the hardware that comes with it. It comes with two different sets of bolts. We have a long, I'm going to call it long bolt, and then there is a short bolt. So they do give you a selection of bolts depending on, you know, what size your terminals are. And like, you know, if you're running them in parallel, you may have two terminals stacked. And then they have color-coded caps to go over the top of the bolts. All right. So, you know, not a big deal, but little stuff that comes with it. Okay. Anyway, they are packaged. Whoops, what is going on here? My camera is getting too hot. Whew. Okay, there you are. Man, okay. Anyways, they are packaged very well, okay? Each of these batteries comes with a It's a pretty heavy duty foam insert right here already. Let me get this thing out of here. They are quite heavy for a lithium battery, I can tell you that. Okay. All right, there it is. So now let's get you back down here to reality. All right. Okay, so anyway, let's get the packaging off of here. Okay, so there it is. They call it 12 volt, right? But you know, anyway, 310 amp hour, built-in 100 amp BMS. That is for discharge. The charging current is a 50 amp charging, but again, remember these are going to be in parallel. So in theory, we can draw 200. We can charge at 100. Okay. They have low temp cutoff, over temp cutoff. They have a low voltage cutoff. All of the specifications for that are in the book. I think that anyway, also the voltages are in here, like for charging and everything like that, which these are going to charge at the same. What is going on with my camera here? Anyways, these are going to charge at the same voltage as my existing lithium batteries, and they charge at 14.4 to 14.6. And then their resting voltage is going to be somewhere around 13.4 to 13.5. Now I say resting voltage. When you first shut the charger off and you let them sit, they will rest at a pretty high voltage, but they're going to naturally bank out around 13.4. All right. So anyways, let's get the camera swapped around here and I'll show you some stuff on the battery. Hey, how's it going? Paintwork turned out good. It's nice and shiny now. Anyways, back down here to reality. So one of the first things I noticed when I took the battery out of the box was just how heavy it is actually for a lithium battery. Now it is far lighter than a traditional AGM 8D battery. Trust me, because my spleen is still in my body. And anyways, as you can see here, not recommended for starting cars. And again, lithium technology is catching up with starter batteries. They're already using them in power sports, you know, ATVs, boats, motorcycles, and stuff like that. And again, there is a company that is building these for big trucks now, and they are working awesome, but they are pretty pricey. Anyway, like I say, what I did notice was the terminals here are quite hefty. M6 as kind of standard, but they're pretty deep and they're pretty hefty. A lot of thread engagement in there. A lot of times that's what happens on like raw cells, is the thread engagement is really shallow and they're very easy to pull those threads out. So you have to be kind of careful with that. But anyways, each of the terminals is epoxied into the case. That is pretty awesome. They are stout. And I like the fact that they did epoxy that so that no intrusion will get in there from the weather or whatever. But I mean, it's not really going to happen anyways. And again, not that it makes a difference, because a lot of them will just stamp it plus and negative, but these are color coded as well. The case is fully sealed. There are no seams honestly in it, so it's kind of like a vulcanized plastic. And it just seems to be, it's pretty darn nicely built. And again, just for the weight of it, I don't know, we may weigh one just to get a weight up there. But anyway, let's turn it over here on its side. Again, there's it's not like the cap is just pressed down over it and clipped. It's actually a solid seam in there, and you can see where they probably put it together originally. But again, there's not an obvious cap to pop off of these. So it's a pretty solid case, very impressive. And I've kind of wiggled them around and moved them around a lot. There's nothing shaking around inside the battery, so that's pretty awesome too. So let's hop up here now into the truck, and let me show you what we got going on already, and we'll talk about that. Anyway, let's get up here in the truck. Get some light on in here. There we are. Hello. Okay. So again, if you watched the previous video, you know that we added 620 amp hours of lithium batteries. And those lithium batteries are right back here underneath the compartment, and they fit perfectly in here, and they go kind of almost all the way across the truck. We'll walk over on the other side too, so we'll get there. And then here's our breaker box, where our generator power is coming in and our power is going out to the loads and everything like that. And so we have a breaker for the mini split, a breaker for the AC to DC lithium charger. And this is the other breaker that I was talking about. I wired in a circuit kind of temporarily where we can power the mini split off of our 3000 watt inverter in there. I don't know what keeps going on with this camera. And so what I did was I just hooked up a plug here, and we use I got some cable run to that plug that's for 50 amp service, right? And then I just got this temporary plug made right here. So all I got to do is plug this into here and come over here, and I switch the top breaker off and I switch this breaker on, and we can now run the mini split off of the lithium batteries, which are connected to the 3000 watt inverter, which all gets its power through this 300 amp fuse. And also we have a 500 amp smart shunt. So if something goes wrong, or we get out of the parameters that I have programmed into the Renogy management system, like low voltage, over voltage, the smart shunt will actually shut off as well. And that is tied in through the grounds. So it will actually open the ground on everything, and it will cut the battery power to the whole entire truck. All right, so that's where that is. Let's walk around the other side and get the other compartment door open so we can try to get us a little bit more light through there, and we'll talk about the other batteries. There, we got a whole lot of stuff piled up in there, that's for sure. Get back over here now to the camera. A long walk around there. This truck is from very tip to very tip is 37 foot 9 inches long. We got a little bit of light going on there. So again, this is the brain side of the whole lithium setup, really and truly. As you can see there, that's one of our, that is a Dali 100 amp BMS, 100 amp discharge, 50 amp charge. And again, our main fuse, our main shunt here. This cable right here, it's kind of, I know it looks a little Yankee in here right now, but this cable actually comes from our chassis battery setup, the 4 AGMs, and then they all come and they tie into here. But every ground on the truck goes through the smart shunt. So let's hop over to the other side and I'll show you that from a different viewpoint. All right, and this is from the passenger side of the truck. And again, there is our other Dali BMS. So there's one mounted on each end of the battery. And up in there is, so there's actually 8 3.2 volt raw cells. Each set of 4 is wired in series. The 2 sets of 4 are then wired in parallel. Okay, so that's how we can discharge at 200. We can actually charge at 100 because the BMSs are run in parallel. Now, those batteries fit perfectly like behind this storage here. So if you go inside the truck, this is our main bench up inside, and where our dining room table and stuff is above us, and then all our rear air conditioning and heat and everything is right here. So when I originally set out to do this, really the 620 amp hours was, I mean, it probably still is plenty, but hey, if you can have more power, you need more power. So now I'm going to actually take all of those out so that we can add in the additional 620 amp hours. But with that, I kind of had a decision to make. I could stack the other 2 batteries right here because again, the cool thing about lithium is it can go upside down, right side up, in ways, back ways, up ways, down ways, whatever, vertical. It doesn't matter how you put them. Lithium can be stacked any way you want to. So really and truly, I already know that the 8D battery is exactly as wide as those are. So I could slide the other 2 batteries along this back wall. I can put, one in there and then put the other one on top of it. Whatever. I had a multitude of where I could put those batteries, but we don't have a lot of storage on the truck necessarily. We have plenty of storage for what we do, but we don't have a lot of storage on the truck necessarily because we don't have toolboxes in our beds. Now, getting away from the batteries for just a second, let's talk about that. by not having boxes underneath the bed of the truck, it gave us other opportunities, like the mini split can be mounted underneath there. The other side is where the generator is mounted, so I had room. Now, if I had toolboxes in here, I wouldn't have had all that room. We would have had to do something else for the mini split, which there's plenty of options for that also. So with that being said, we're going to move the batteries out of the truck, and we are going to put them in right here. Okay, so we might as well gain all of this real estate back by moving the batteries simply just behind the cab. Essentially right now they're just in front of the cab, right? So if we pop up here, a ton of room for batteries, and even with the 1240 amp hours that we're going to be putting in there, we will still have tons of room. So what we're probably going to do is we're going to insulate this box. Again, they're lithium. It's the only kind of drawback to the lithium is cold weather. Now we live in Southeast Texas here, so we're really not faced with brutal winters, but we do travel in the winter sometimes, and I don't want them to get too cold. So we're going to insulate this box with just like a 1-inch foam board, coat the bottom all around the top. We'll piece some stuff in here, and then I can simply lay in. I can just drop. I don't know if I'm going to use a DC, a heated blanket, or an AC DC, whatever. I don't know. And we might just do a DC heated blanket. We can hook up a little thermostatic control. With a relay, we can mount the thermostat right on the side of the box out here. If it gets down below whatever, then the blanket would just kick on. And with this box being insulated, it'll keep them plenty warm in the wintertime. So that's the idea. And also by doing this, then we can just mount our battery disconnects right here on the side, on the outside. We can kill the batteries or whatever like that. And since, again, we can lay the lithium however we want to, we're going to stack them in here on their sides, and we'll gain a whole lot of room. So that's the plan. We're going to take all of the lithium battery out of the truck and mount it in this box because, again, I cannot get in and out of it when the Jeep is on the truck, right? And then this has become a perfect spot right here. This is our table. We just mount a table right there. We keep it tied up. That's perfect. This is where all of our mini split comes out of the back of the cab. A whole video coming about the mini split system. This is the drain. This is all the refrigerant lines and all the electrical cable that runs down to the main unit, which is underneath there, okay? And then our generator is right under here. And this is our two 30-pound tanks, 60 pounds of propane for the generator. It has an automatic switch that it will convert from one tank to the other as they get empty. So anyway, we're going to do a whole entire walk around series also on the truck showing absolutely 100% of the systems that are installed. But right now, let's focus on getting these batteries out of there and start laying them out in here to get more power. So this is our AC to DC lithium charger. This is just a 20 amp charger, and it just uses this, I think it's called an Anderson style. I don't know, that's a name brand, but anyway, just kind of connector. And then we just got it hooked up to the batteries. And then I had wired in a plug right here that's tied into the generator. And anytime we fire the generator up, well, the AC to DC charger just comes on. And again, it only charges at 20 amps, so it's not any kind of a huge milestone of putting a lot of power into them, but it does fine. So we're going to keep that. But again, like I said, since we're going to be going to 1240 amp hours of batteries, we're going to go ahead and add a DC to DC charger to it as well. I went ahead and selected a 60 amp charger. And again, like I said, I depleted those pretty hard and I cranked the truck up and we were drawing nearly 80 amps. So I'm just going to limit that to 60 amps down, even at 75, 77 amps, checking the computer and stuff in the truck. We weren't in any danger of being, overloaded on the alternator or anything like that. But if we are sitting at idle and it's trying to draw that much amperage, the alternator is going to try to heat up on us. So we're just going to limit that by going ahead and installing a DC to DC charger. So anyway, we're going to work on getting the rest of the battery connections undone, and so we can get those batteries slid out of here. All right, so this is the battery that I built just not even a couple of years ago, and like you can see it's just 8 raw 3.2 cells, and each set of 4 again are in parallel, are a series, making a 12-volt battery, a 12-volt battery, and then those are wired in parallel through the BMSs and stuff like that. So, let me get this out on the truck, and I'll show you how I built these. Okay. Alrighty, so here is my homemade battery. Now, I have reconfigured these. I used to have 2 individual 4-cell batteries, and they were in their own cases and stuff like that when, because these used to be in the motorhome originally, until I bought some replacement ones like this and stuck in the motorhome to reconfigure these, because this configuration fit in the truck a lot better at the time. Now, since I've been buying these actually fit perfectly in the truck right through there if you flip them on their side. And I mean, it is exactly that width, and it slides right up in there. And then the terminals actually butt up right up against this plastic strip right there, that black plastic strip. The terminals actually go butt up right against it, so they fit perfectly. But anyways, keep in mind, if you decide to build your own batteries, which these are very, very, very cheap now, you can almost buy even the individual cells cheaper than a complete battery, really and truly, if you shop around. Anyway, keep in mind, raw lithium cells, again, are not in a case, right, like this. So they need to be compressed when you assemble them. That's why this is the way it is, okay? And also, you need to insulate between each cell, because these cells are just shrink wrapped. If you cut all this shrink wrapping off of here, you can actually get a charge current through the outer case. All right. So that's what this is all about. I have 2 end caps. This is just a long rod, and these things are really compressed together so that when you charge them, they don't expand. Okay. And then again, each set of 4 is in series, makes one 12-volt battery. Each 12-volt battery is in parallel. This is our main hot cable, and as you can see, yes, it is taped up because there is a lot of amperage going on in here. And hey, here's something for you, right? So this is the size cable that I use, which is number 2, I believe is what it was. This is a 200 amp BMS. Look how tiny the wire is that Dali. Now, Dali is very, very well known. They build high quality BMSs. They really do. That wire right there is very small. That's 200 amps can be drawn through that, right? So it's surprising how much current can actually go through a small cable. I know they always say, oh, use the biggest cable you can get away with, and I still believe in that also, really and truly, but it doesn't take a lot of cable size, really, to be able to draw a lot of current. But anyway, that is our homemade battery, and compared next to the really pretty battery, it's about right. As you can see, we have 1, 2, 3, 4 cells here, right? So lined up with the case. So those 4 would go up, and then you'll have your main circuit board with all your low temp, high temp, your BMS and everything, and then all your wiring connections and stuff like that. So again, the size of the battery is about right. You can buy these cases blank, and you can load all this stuff into those blank cases, which is what I used to have. I just had regular like Group 31 cases with these all piled in there. But anyway, like I say, now that we got all that out, you can see how much real estate we really gain inside the truck for storage. So that was the main reason why I was going to go ahead and put these, in this box. So anyway, now we're going to go ahead and start getting the batteries laid out in the box just to see how we want our configuration. Because again, I may take these apart, because we can put these any way we want to, as long as each set of 4 is wired in series and each group of 4 is wired in parallel with the other battery, right? And then once we figure out exactly how we're going to do it, then like I say, we're going to insulate this whole entire box in here so that we can keep it warm in case we're traveling in the cold winter months. not exactly sure how we're gonna. We have multiple ways we can do this up in here. Maybe something like that. Well, let's get the other battery opened up. We'll get it laid down in here, and then we'll take you for a show and show you. Instructions? Who needs that? Well, not sure if I like that or not. It would be a problem, but let me show you what's going on here. So if we flip them on their side, they fit in there exactly perfect. There is a gap between the batteries, but you will notice that it is very, very close. I mean, we could build a spacer to go in there so that they would never touch each other. And then we can run our cables out this end, but that is too close of a gap for me. I'm not really comfortable with that. And we definitely don't need those touching each other because, you know, our positive is on top and negatives on the bottom on this side, and then we're flipped on this side. So it'd be a bad kaboom. So anyway, I'm going to drag these back at her and let's reconfigure them a different way. Okay, so I guess something like this. You know, again, my homemade battery is not quite as pretty as these other two, but the box is just not quite wide enough to put two side by side where they're laying flat like this. So one has to be on, they have to be on their sides to go next to each other. So anyway, there's nothing wrong with this, right? I mean, that's 1,240 amp hours of batteries in there. And I do, if I really wanted to, I could get another one of these, lay it on its side, slide it right down in here, and we could have like, what, 1,550 amp hours of batteries. You know, and again, that's based off a 310 amp hour. I have mixed feelings about battery capacities. So you have to remember, technically every battery in here is 310 amp hours, right? This is just two sandwiched together. They're still 310 amp hours a piece, so they're all the same. There's a lot of debate on whether you can mix capacities, because they do make this size battery in a 400. They even have a 500, a 600 now. I mean, in theory, you could put another 600 in here, lay it on its side. I mean, we already have 1,240. I mean, we added another 600. Again, the limitations of lithium is really crazy now on capacities. I mean, in theory, we could take all these out and buy 4 600s. I mean, you can put as much power in here as you really want. But I think this is going to work out fine, this configuration. And probably what we'll do is we'll mount the DC to DC charger just down in here flat along the floor. It's a nice convenient place. It's out of the weather. It keeps our DC to DC charger nice and protected. This is going to be insulated, so there is a heat situation when it's hot outside. So to resolve that situation, probably what we'll do is they actually make some little cooling fans that have unidirectional ducking on them, depending on how you mount it. So we will probably come in here and we'll just mount a fan, probably right here in this corner, and then we'll mount a unidirectional duct down here. So we'll set up, we can do it multiple ways. I can just put a toggle switch on it. I can put a thermostatic controller on it, however I want to do it. But anyways, we may set it up like that so that, you know, if it gets over like whatever the rating is on the battery, I think it's 120 degrees, honestly. They're pretty high. Anyway, we can make it where that fan would automatically kick on. It would start pulling air in, and then the unidirectional ducting would open and it would just let it exhaust back out. And then when they shut off, the ducting just closes back off. We may do that, and We do have a little bit of a space between the two here, but remember we're still going to insulate the box. And I think it's about a 1/2 inch foam board, so that's going to take up 1 inch. So these are going to slide down in here actually tight once we get all the foam board down in there. So it looks pretty good actually. I mean, it gives us some room to build some cabling. You know, these will be paralleled together and come out. We'll just have 2 cables, and then we have our this group of batteries is already paralleled, so we can just tile those in there. We'll get a bus bar, just mount it. And then that would be a real easy run to go into the DC to DC, and then all we would have to do is just run the main cables, which are already technically ran. I already have primary cables coming from the chassis batteries on the truck now up into the compartment. So we can just, we can put again, a terminal block for a junction lead in there, and we could fuse it if we wanted to, and then we could we'll just jump right out of there and jump right back into here and tie it right into the DC to DC charger. So anyway, something like that. Anyway, there it is. A whole lot of lithium power going on. So we'll get these drug back out of there. I'm happy with that configuration. We'll get them all drug back out of there and get some insulation put in there. All right, so we had this foam board installation, and we have just cut it up. And now we have a gigantic ice chest. Okay, hold up. Slight change of plans. I made a small miscalculation in my insulating board. I knew when I dry fit the batteries in there that the clearances were going to be pretty tight, and I accommodated to know that I had at least a 1/2 inch to spare. What I didn't think about is the foam board is 1/2 inch thick, but that's double the thickness, so we actually lost 1 inch this way and 1 inch this way. So when I went to fit the batteries back in there, they did not fit because, well, I'm not a mathematician and I measured wrong. So anyways, back to Lowe's. We just went and bought a roll of the 1/4 inch. It comes in a roll like this right here. It still has an insulating value of an R7 factor, just singled. So that is plenty, right? Because again, we're not trying to make a refrigerator, an icebox, or a sauna. We're simply trying to keep the internal temperatures stabilized. And as we're using the batteries, if it is below freezing outside, then our BMS and our batteries will naturally give off a little bit of heat as we draw on them. And vice versa, when we go to charging, they will get a little warm. So all we need is something just to regulate the temperature in there to keep it from getting below 34 degrees. And really, frankly, if it's that cold outside, well, I'm probably not going anyways. And the BMS in my home-built batteries and the ones that I've been buying do have low temp cutoff that if it gets below 34 degrees, I'm sure there's a plus or minus factor in there, so it technically could get to freezing. But anyway, they will shut off on their own. I'm also going to look into getting like a Bluetooth temperature sensor so that we can mount it in there, and then I can just put the module, either an app based on my phone, or I can just stick a little display inside the truck and we can monitor the temperature inside the box like that. If it does start getting too cold, we can, which I may do anyways, I can just install a couple of like 12-volt tank heater pads. Like for an RV, you can buy 12-volt pads that go on tanks, your waste tanks and your water tanks, which we have heated bays, no worry in there. But I will probably get some anyways so that I can put them on the water tank, since it is going to be mounted underneath the truck somewhere, and I'll have to keep that tank just above freezing. We're not trying to warm it up. We're simply trying to keep it above 32 degrees. So 33, 34 is fine. It can't freeze, right? Anyways, small calculation error by me. So anyways, problem solved. We now have a really pretty shiny, but the bottom was fine. So I left the 1/2 inch layer on the bottom. It was just the outside perimeters. Anyway, there we go. One insulated box. All right, and there we go. Just like that. 1240 amp hours of lithium battery. All right, so I've got all of them wired up in parallel, the group of 4 here, temporarily, as you can see here. I did mean to add that the battery manufacturer says that you can only connect a maximum of 4 in parallel. Maybe somebody smarter than me knows why. I really don't know, because I mean they're essentially acting as one battery, but I don't know if it has something to do with the BMS or whatever. But anyways, we have went ahead and wired in temporarily also our connector here for our AC to DC charger. The batteries do come shipped. I think they said they're about 50% state of charge. So they're resting right now at 13.2 volts, which is exactly where they should be resting. The resting voltage in the literature says anywhere between 13.2 and 13.4. So they're right on the money. So anyway, we're gonna go ahead and hook up our AC to DC lithium charger here and just let them charge to get them up to full capacity and everything like that before we just start wiring them into the rest of the systems and stuff. So let me get the connector hooked up here. There we go, got that plugged in. And then, like I say, we're just gonna let them charge. We'll see what they're taking. It's just only a 20 amp. It's only a 20 amp charger. So like I say, I expect that they're gonna be taking the full 20 amps. So anyway, we'll just set our meter here. We use a Fluke. We really love these things, they're awesome. It's a clamp on amp meter. It reads AC and DC. So we're gonna set it to AC amps. And let's see what we've got going on. Yep. So anyway, that's it for now. We're just gonna let these rock. Probably gonna take all night at 20 amps to get them up to full capacity. And then our DC to DC charger should be in tomorrow, and we will resume with getting the rest of them wired in. So for now, case closed. Well, it's the next morning, 12 hours later. We're still charging. Let's see what we got. .4 volts. And let's see how many amps we're taking in now. Switch this over to DC amps. Oops, sorry. Come on, get out of there. We are still taking in almost 19 amps, 8.8 amps. So I knew it was going to take a long time to pack all these things, but anyway, we're just going to let it run throughout the day. I mean, we'll get there eventually, right? All right, guys, so it's been about 20 hours, 21 hours or so, and you can see our voltage is up to 14 volts now. So I'm fine with that. We're going to go ahead and shut the charger down. Well, let's see how many amps it's taken first. And then we'll know, I mean, how much the lithiums are still taking. Now, they only get charged to, I think they said they shipped it 50% state of charge, discharge, whatever you want to call it. So, you know, let's swap over to amps DC here. Yeah, see, we're not even taking a half an amp anymore off the charger. So anyway, I'm just gonna let it rock like that. We're gonna go ahead and get everything disconnected on that. Let me show you what I've been working on in here now, and this is kind of getting the DC to DC laid out, how we're gonna do it. And yes, it drives me nuts that the logo is upside down, but for some dumb reason they put the input and the outputs on. Anyway, this is the input side coming from the truck chassis alternator, and then this is going to go out to the lithiums. So I just stuck it in here because that's where all our fuse block and our shunt is and everything like that. And I already had all the cabling run from the truck chassis batteries, which are housed underneath there. So I already had all the cabling ran into here, so it's really easy to tie that into the DC to DC. So I'm going to start working on getting the cables connected up. There's no reason to show you all that. I mean, surely you know how to connect cables and battery cables. And on the schematic here, it shows, you know, where everything goes. This particular DC to DC does take an ignition energized to make it start charging. I did think about going ahead and getting the Renogy one just because it is a voltage sensing DC to DC. You don't have to do nothing except connect your battery cables, and as soon as you crank the truck and the alternator voltage goes up, it automatically starts charging. Whereas this one will require a keyed ignition. But that's super easy, not a big deal. Our jackalope right here, we can actually tie into the ignition accessory wire on that, or we can even tie into the ignition accessory wires right here in this bundle. So it's easy access, not a big deal. Anyway, oh, here's one tip I would say for you. If you are going to be doing any kind of cabling, heavy cables, big battery cables like this with these ends, get a hydraulic crimping tool. it will save your life, and they're super cheap on Amazon. I bought this one like 5 years ago. I paid like 60 bucks for it, and I've probably done hundreds of cable lug crimps on it on heavy cable. Get a hydraulic crimping tool. It's the only way to go. Anyways, I'm going to start getting the cabling laid out, getting the ends set on there, get the DC to DC connected up, and then we'll move on back outside here, getting our cabling ran up into the battery box. All right, well, let's see if we can find us a switched wire here in the jackalope. So we got nothing with it off. Let's fire it up and see what we got. Oh, there she is. 14 volts with the truck on, no voltage with the truck off. So that's what we need. We need an ignition switched wire so that we can activate. Anyway, when we kick the truck on, it will energize our DC to DC charger. And we'll just verify that. Make sure it de-energizes. There we go. Ignition switch. We'll get it straight out of the jackalope. I keep mentioning the jackalope, and I know that you guys that are HDT RV haulers know exactly what that is, but if you're in the commercial truck side, you may not know what a jackalope is. Anyway, it was a system that was developed to take your commercial truck wiring for your trailer and convert it over to a real easy to use system that makes it like a standard 7-way RV plug. And that's all it is. It's just a conversion box. But it's a real cool plug and play situation where you literally just take the wiring harness that originally went to your trailer plug, you reroute it up in here to the box. It's all color coded. It's labeled in there. You plug all the wires into it. Your harness comes out the other side, right to the back of it with your 7-way RV plug. Super simple. So, the input voltage side from the alternator is reading 14.1. The output side to charge the lithium batteries is reading 13.3. After several hours on the phone with tech support, all of that has to come back out. The DC to DC is defective. Huh. Well, stay tuned. I guess we'll have to continue this in a part 2 series. Yeah, that blows. Okay, I did end up ordering just another DC to DC charger. I got one from Lithium, which is where I should have got it from to begin with. Anyway, this is just a 40 amp model, and again, it takes an ignition source wire to activate it when you crank the truck up. As you'll notice, as I did crank the truck up, the amperage jumped right up to 38 amps. It is working great. Now, the green LED there, you'll notice that when I shut the truck down, that LED will slowly fade out. That's due to the capacitors inside the DC to DC being charged, and as they discharge out, it will completely shut the DC to DC off. Okay, I did want to show you guys one more thing. If you remember, I was talking about the way we had a bypass built into the mini split so we could run it off of the inverter, which is tied to all the lithium battery bank. So we're going to fire up the mini split right now just off of batteries. And so the way I do that is I shut my breaker off that comes from our generator supply. I shut that off, and then I have a temporary cord here. It's just wired into the breaker box. We're going to plug that into the inverter, and then we're going to swap over here and we're going to push that plug on. All right, let's hop up in the truck right quick and let's fire up the mini split. So of course, truck is not running. We are entirely running off of lithium batteries right now, and we're drawing about 3.9 amps. So anyway, let's fire up the mini split. So we got this is a 3000 watt inverter. This inverter does have a pass-through function also. So whenever we do fire up the generator, there's a line that comes from the generator breaker box, and it goes into the inverter, and when we fire the generator up, the inverter detects the 120 volt, it bypasses the batteries, and it just becomes a pass-through inverter. So anyway, we've got the mini split fired up. Start watching the amperage here. Now guys, it is hot outside, okay, and it's hot inside the truck, so the mini split is going to be ramping up. Remember, it's a linear compressor and a linear blower motor, so it's not a hard start. It's going to ramp up very slowly. And remember, we're running entirely off of the battery bank right now. So the 100% is the total battery capacity remaining. I only have it set at 1200 amp hours, even though we have 1240 amp hours. It's just kind of a buffer. The next number down, that's the time remaining on the battery at the current amperage being drawn. Of course, our left bottom number is the voltage, and of course the right number is how many watts we're drawing. And the mini split is already cold. It is blowing nice and cold already. I got it set on 72, but anyways, as you can see, so you can notice that the compressor is ramping up now because the amperage is slowly going up as to what we're drawing off of the inverter. So we're at about 1,000 watts being drawn. This is just a Renogy battery monitor. That's the smart shunt. This is just a little display for it. What are we up to? We're already up to almost 90 amps. 91 amps. We're going up. And again, remember, it's hot outside. The compressor on the mini split is slowly ramping up to 100% cycle. It's going to take a bit. Bear with me. As far as the inverter output goes, remember we have a 3,000 watt inverter. The fan has not even kicked on yet on the inverter. It's 96, 97, 98. So you can see the compressor is ramping up more and more due to it being so hot inside the truck. 110 amps now off the lithium batteries alone. So 113 amps. Let me turn this dude down some more. I want to make the compressor draw. I want to make the compressor draw pretty hard off of the lithiums. Okay, see, the amperage is already going back down. Because the temperature in the truck is already cooling off, just that little bit of short of time, the temperature in the truck is already cooling down, and I had it set on 72 degrees. So you notice that our amp draw is going down because, again, the linear compressor on the mini split is starting to back off some. It doesn't need 100% compressor. The fan just finally kicked on the inverter down there. All right, so you'll notice that the amperage is going down that we're drawing, right? And the time, which is underneath the 100% capacity over there, the time is now going back up. That is time remaining on the batteries if we keep drawing at the current amperage. All right, so you notice as we're kind of stabilizing again, right? 96.5 amps. Again, remember, this is entirely on battery alone, okay? Now I'm going to turn the mini split. Let's turn the temperature up. I want it to start ramping down a little bit, right? Just kind of simulating that, you know, it's on later in the evening and the truck is nice and cool. All right, you see how much we dropped off there just that quick? I turned it up to 75 degrees on the mini split. Again, you'll notice that our time remaining on the batteries, how much it is jumping up now. Anyway, point being is, you'll notice that when we were at max, what was it, 100 plus amps we were drawing off the batteries when the mini split was really cranking it pretty hard. We were still at, I'll have to go back and look at the footage myself, but we were still at about 11 to 12 hours. So that is 11 hours alone if we were just to run the mini split entirely off of the lithium battery bank with nothing else. Anyway, that's what I had hoped to gain. I really wanted to be able to look at 97 hours now because the mini split is ramping down. right? We're not hardly drawing anything. Anyway, I'll go ahead and shut it off. Shut the mini split back off. Anyways, guys, okay, point being is you saw that, right? We can run the mini split entirely off of the lithium batteries, no generator, no truck running. The cooling fan is on the inverter now, because I mean, God, we were drawing, you know, some serious current out of that thing. So anyway, back to it. So anyway, you saw that we had at least 11 hours on batteries alone, and that was still with the mini split, you know, drawing a pretty good amount. Once the truck gets cooled off in here and the mini split just throttles way down where it's just regulating the temperature inside the truck, that time remaining is going to go up. So that, again, that was 11 hours at really, you know, just sucking the heck out of the batteries, right? So we can easily go overnight without even running the generator, just running nothing but the lithium batteries on there. And I mean, we do have a generator, so it's not like, you know, if they did get low, I do have an alarm set on the battery monitor. We would know when the voltage got low, and we could fire the generator up. And of course, when we turn the generator on, that inverter immediately goes to pass through. So we would stop using the battery altogether, and it would just switch over and start drawing off of the generator. Also, I do have an AC to DC, you know, lithium charger. So again, as soon as we fire up the generator, the lithium charger is going to come on. It's going to start charging the batteries again. Anyway, that's what I had hoped to gain, really. You know, I mean, we went to 1,200 amp hours of batteries, and I now have the capability to be able to run the mini split. No generator, no truck running. I don't even have solar on it yet, right? So we're going to do some flexible, probably about 450 watts of flexible solar panels on the roof. I may build a little rack just inside. You know, I don't want it to come back out over the truck, but just maybe from here across, we can build a rack. I mean, we can easily put, you know, 800 watts of solar on the roof if we really wanted to, but I'm not going to go that far. There's no reason to. I mean, we'll have a trailer by then, so. But I am going to do about 400 watts of solar on the roof. And again, like when we go to the beach, or if we're just out boondocking, you know, up in the mountains somewhere. I mean, during the day we start drawing solar. I mean, again, it's even better. So a lot of people complain because I talk too much in the videos. So too bad. We share a lot of information, so that's why I talk so much. Anyway, I had a guy comment, it's like, you need to stop talking so much and just show it. Well, I can't show you diddly squat without explaining it to you. So that's the whole point of a lot of talking, is just to explain it all. Anyway, we did have a little bit of trouble with the Volvo DC to DC charger. I'm not going to knock them or anything. I mean, I just got a defective product. Their tech services was easy to work with. They said, sorry, you know, yeah, it's bad, send it back. I bought it through Amazon. We immediately got a refund just like that. Turned around and bought the Lie Time, which I should have bought to begin with, guys. Anyway, the Lie Time works perfectly, and we're happy as can be. So there we go. One nuclear-powered lithium battery bank install in the HDT truck.